Greetings, Vaughnables. You haven't heard that since the last recording, but Ms. Vaughn and I were talking about this percent of change that we're going to be dealing with for tonight's homework, and we thought it'd be better for you to watch this video than to see what is actually in the textbook. I think this might make more sense for you if you actually watch this video instead. Now, you notice up at the very top, we have put together kind of a formula that I think you can use. I'm going to highlight it right now. So we'll take the highlighter. Basically, every single one of these problems can be solved this way. You start with the original amount, whatever it may be. You're either going to add or subtract a percent times that original amount, and it'll always give you a new amount. And if you do this way, I can almost guarantee you're going to get every single one of them right, if you truly understand what's going on here. There are other ways to do it, and the book will show you different ways, I'm sure. But I can guarantee also that many of you will get half of them right, and you get the more difficult ones wrong if you don't follow this method. So give it a go, take a look, see if it makes sense to you. So Ms. Vaughn and I are going to show you 4 different examples, and then from there you can go ahead and practice the problems and your homework. So number 1 talks about a pair of boots originally cost $120, but were marked up 25%. What is the new price of the boots? So if I follow what's highlighted at the top of the page, the original price of the boots this time is just $120. So I'm going to start with $120. And this time I'm going to be increasing them, marking them up, so it's going to go up 25%. So I'm going to go plus 25%, and we write it as a decimal. 25% of what? Well, the original amount. And the original amount was $120. So I'm going to put another $120 times that 25%. And then that's going to equal what the new amount is. And that's the unknown. That's what we don't know what we're looking for. So I will call the new amount, I will call it x. So all that's left for me to do right now is actually solve this equation. So 120 is the same. 25% of 120, if I use the calculator, I think it comes out to be 30. And then from there, that's going to equal the new price. So 120 plus 30 is 150. So the new price is going to equal $150. And that's how I do the first example.
Hello, everybody. We're going to do another example, and it's a little bit different, but we can use the exact same equation as we did in the previous example. So for reading this, it says last year there were 381 students in the 8th grade, and this year there are 355. By the way, that's false. I made up those numbers. Anyway, what is the percent of change to the nearest whole percent? So if the original number, the one that happened first, originally last year, is 381, you're going to put that in the equation, the original amount. Now it's going down, so instead of adding, I'm going to be subtracting the percent, and we don't know the percent, that's what we're trying to find, so you're going to use an x, times the original amount, which is again the 381, and that's going to equal the new number of students, the new amount, which is 355. And we have pulled all the information out, and now we have an equation to solve. So we're going to subtract our 381 from both sides. And right here it says negative x times 381, but I know we've said before that we like the coefficient in the front, so I'm just going to say that this is a negative 381x, and that equals a negative 26. Okay, so now we have x being multiplied by negative 381, so we divide negative 381 on both sides. And x is approximately, and it's a decimal, 0, 6, 8, and it keeps going on and on. But I said to round to the nearest whole percent, so I'm going to round to 7%. And that's my final answer.
All right, hello again. Now, the last 2 examples Ms. Vaughn and I are going to show you are actually the type of examples that if you don't use this way of doing it, there's a good chance you're going to get it wrong. So I'm going to read number 3. It says, Sean sold his cell phone for $275, which is 76% more than he bought it for. How much did Sean pay for his phone originally? Now you notice in this particular problem, we have no idea what he originally paid for it. So in this time, our original amount is going to be our variable. So the original amount, I will say, is going to equal x. So when I go through and use this formula, the original amount is X, so I'm going to write X plus the percent is going to be 76%, so it's increased by 76% of the original amount. Well, once again, the original amount was X, so X plus 0.76X. And that's going to be the new cost, which is what he sold his phone for, which is $275. Right, so now I need to clean this left side of the equation up a little bit. You notice we have common terms that are called like terms, actually. And the X has a coefficient of 1, so I add together the two coefficients, and now this time I get 1.76X is equal to 275. And then when I divide both sides by 1.76, I'm going to get X equals $156.25. So the original price, Sean's original price, was $156.25. Now, what a lot of you are going to be tempted to do, and you can do this on your own, you're going to be tempted to take 76% of 275 and then subtract it, and you're going to find out it's not going to work. So if you go back through and you check, if I go back to 156.25 and then I take 76% of it and add it to 156.25, it will turn out to be $275. And again, if you don't do it this way, there's a good chance you're probably going to get it wrong. So we're just trying to head it off the path and make sure that you get some good data instead of making mistakes early on.
Hi, it's me again. All right, we're going to do one more here, and it is one of the more difficult ones where you really, really, really need to use this equation that we came up with. So, if a calculator is on sale for 35% off, and the customer pays $91 at the register, how much did the calculator cost originally? So, we don't know the original amount, so we're going to use X to represent the original amount. Now I'm going to subtract because it's on sale. So I'm subtracting the 35%. So 35% of the original amount that we still don't know. And that's going to equal the new price, which is what they pay at the register, the $91. Okay, so the coefficient here is 1. So now we're going to subtract 1 minus 35 hundredths. We're going to get 65 hundredths times X equals 91. A little one-step equation here. Divide by 65 hundredths on both sides. And we get our original price of $140. So be good to your calculators because they are expensive.
Okay, kind of summarize everything that we've done so far. This formula will work every single time. And the problem is some of you are going to say, I really don't want to use this formula. And you know what? You're probably going to get it right about half the time. Because these problems are very, very tricky to do. And if you try and do it the other way, there's a good chance you're going to get it wrong. So we're in algebra. We're trying to understand the idea of using equations. So I think it'd be a great idea for you to take a look at this equation that we gave you, try and apply it to all the problems. Even if you think you can do it without it, try and apply it, make sure you get the right answers. Okay, we'll see you next time.